In this video, let us try to solve these three problems by applying the formula of converting sum to product or product to sum. Please try to solve this problem yourself so that you can apply these formulas and be more confident in solving such problems. So let's start with the first one now. In the first question, we have to prove that tan A, tan B, tan C, tan D will be equal to 1 when we use this equation, which is cos of A minus B by cos of A plus B plus cos of C plus D by cos of C minus D. So let's try to solve this problem now. Now using the given information, let's find the common denominator. So this will be cos of A minus B times cos of C minus D plus cos of C plus D times cos of A plus B. This whole thing divided by cos of A plus B times cos of C minus D, which is equal to 0. Now if we move this to the right side and multiply with 0, so the denominator will be gone. So we would have cos of A minus B times cos of C minus D plus cos of C plus D times cos of A plus B. This is equal to 0. Now let's start applying the formula of cos of A minus B. That will be equal to cos A cos B plus sin A sin B times cos C cos D plus sin C sin D. Then the second part, let us apply the formula, which is cos C cos D minus sin C sin D, and this is cos A cos B minus sin A sin B, which is equal to 0. Now let's move the second part to the other side of the equation. So we would have cos A cos B plus sin A sin B times cos C cos D plus sin C sin D. This is equal to minus cos C cos D minus sin C sin D multiplied by cos A cos B minus sin A sin B. Now in the required proof, we need all the values to be in the format of tan. So to get tan, let us divide both the sides by cos A cos B cos C and cos D. So when we divide both the sides, let's consider the first part of the equation now. So cos A cos B would get cancelled and we would have 1 by cos C cos D plus, in the second part, sin A sin B by cos A cos B would change to tan A tan B, and the remaining would be cos C cos D. Now in the second part, we would get cos C cos D would get cancelled and we would have cos A 1 by cos A cos B plus tan C tan D by cos A cos B, which is equal to minus, now cos C cos D will get cancelled. We would have 1 by cos A cos B minus tan C tan D by cos A cos B times 1 by cos C cos D minus tan A tan B by cos C cos D. Now if you observe here, we have CosC CosD common in the first part of the equation and Cos A Cos B common in the second part. So Cos A Cos B CosC CosD is the common denominator, and that applies in the second part of second part of the equation as well. So we can cancel out all the denominators because they are available on both the sides of the equation. So now we would have 1 plus tan A tan B multiplied by 1 plus tan C tan D. This will be equal to, now just to solve the negative sign here, I am going to change this to tan C tan D minus 1. Instead of writing it as 1 minus tan C tan D, I change it to tan C tan D minus 1 so that the negative sign is removed. It is just for the ease of calculation. It does not matter. Now let's multiply this. We would get 1 plus tan C tan D plus tan A tan B plus tan A tan B tan C tan D equal to tan C tan D minus tan A tan B tan C tan D and plus tan A tan B. Okay, now there is minus 1 also. Okay, now let's see what can be cancelled out. So we have tan A tan B on both the sides, and we also have tan C tan D on both the sides. So when we rearrange the equation, we would get 2 tan A tan B tan C tan D is equal to minus 2. Now if we cancel out the 2 here, so the final proof would be tan A tan B tan C tan D will be equal to minus 1. So this is how we can solve the first question. In the second question, the information given to us is cos of A plus B multiplied by sin of C plus D is equal to cos of A minus B multiplied by sin of C minus D. So using this information, we have to prove that cot A, cot B, cot C will be equal to cot D. So let's apply the formula of cos of A plus B. So which is cos A cos B minus sin A sin B multiplied by, now let's apply the formula of sin of C plus D, which is sin C cos D plus cos C sin D. This is equal to, now cos of A minus B is cos A cos B plus, sorry about that, sin A sin B multiplied by, now sin of C minus D is sin C cos D minus cos C sin D. Now in the proof, we need all the variables in cot format or cotangent format. So cot is nothing but cos by sin. So in the denominator, we have to get sin so that we can get the proof in cot format. So what we'll do is we'll divide both the sides of this equation with sin A sin B, sin C and sin D. So when we divide both the sides of this equation, there would be no change to the actual value of the equation, but it will help us in simplifying this further to arrive at the proof. So let's apply that on the first variable here. So in the first variable, cos A cos B divided by sin A sin B, that part will change to cot A cot B, and the remaining would be sin C times sin D minus, in the second part, sin A sin B would get cancelled and this would be 1 by sin C sin D. Now sin C cos D, here we have to be a bit careful. So sin C would get cancelled and cos D by sin D would be cot D divided by the remaining two variables are sin A sin B plus cos C by sin C will change to cot C, sin D will get cancelled, remaining term is sin A sin B. So the left hand side is completed now. So this is equal to, now let's apply it on cos A cos B. So cos A cos B by sin A sin B will be cot A cot B and the remaining values would be sin C sin D plus this in this part sin A sin B would get cancelled. We would have 1 by sin C sin D. Now in the next part sin C times cos D. So sin C would get cancelled. Cos D by sin D would be cot D by sin A sin B minus, now in the last part sin D would get cancelled. We would have cot C by sin A sin B. Now if we observe these two parts of the equation, the left hand side and right hand side, sin A sin B sin C sin D is the common denominator, so we can completely ignore that. So the equation would basically change to cot A cot B minus 1 times cot D plus cot C is equal to cot A cot B plus 1 multiplied by cot D minus cot C. Now it is just an application of algebra and solving this out. So let's simplify this equation further. So this will change to cot A cot B cot D plus cot A cot B cot C minus cot D minus cot C is equal to cot A cot B cot D minus cot C cot A cot B plus cot D minus cot C. Now let's compare both the sides of the equation and figure out what can be cancelled out. So there is minus cot C on both the sides, that can be cancelled out. We have cot A cot B cot D on both the sides. Then yeah, those are the things we can cancel out. So now this equation will further change to 2 times cot A cot B cot C is equal to 2 times cot D. So basically we have cot A cot B cot C is equal to cot D. So this is how we can solve the second question. Now let's try the third one. In the third question, the information given to us is y times sin A is equal to x times sine of 2b plus a. Using this, we have to prove that y minus x times cot b is equal to y plus x times cot of a plus b. So let's rewrite this given data. So we can write this as y by x is equal to sine of 2b plus a divided by sin a. Now in the previous questions we have applied a rule of ratio called componendo dividendo. So this is a very important ratio, a rule of ratio that you can apply, which says that when a by b is equal to c by d, then a minus b by a plus b is equal to c minus d by c plus d. So we are going to apply that here. So the question would change to y minus x by y plus x is equal to sine of 2b plus a minus sine a divided by sine of 2b plus a plus sine a. Now we are going to apply the formula of sine of c minus d and sine of c plus d. So let's write that as y minus x by y plus x will be equal to, now sine c minus sine d is 2 sine c minus d by 2, so 2b plus a minus a by 2, and cos of c plus d by 2, which, so it will be 2b plus a by 2. This whole thing divided by, now in the denominator the formula we are going to apply is sine c plus sine d, which is 2 sine c plus d by 2, which is 2b plus a by 2, and cos of c minus d, which is 2b plus a minus a by 2. So let's simplify this further now. We can cancel the 2. Then in the denominator we can cancel the a here, and in the denominator, in the numerator we can cancel the a, and the denominator we can cancel a in the cosine function. So we can rewrite this as y minus x by y plus x is equal to sine b multiplied by cos of a plus b divided by sine of a plus b multiplied by cos b. So this is nothing but, now cos of a plus b by sine of a plus b is cot of a plus b. So we can rewrite this as y minus x by y plus x is equal to cot of a plus b divided by, now sine b by cos b is tan b, and tan b is 1 by cot b. So we can write this as cot of a plus b by cot b. Now we just cross multiply and we get the proof. So cot b times y minus x is equal to cot of a plus b times y plus x. So this is how we can apply the formula of converting addition to a product form or subtraction to a product form, and we can arrive at these proofs. So please watch these videos up to this point and solve all the questions by yourself. There is nothing wrong in trying one question multiple times. And thank you so much for watching. Please share this video with your friends. I'll see you in the next video.